Okay guys, good news. Today we've got a fairly easy project, and it's our last project before we start our final project, which is our 2D platformer. Remember, something like a Mario or a Sonic game. And what we learn here today is going to be critical to being able to create a platforming game. It should be clear that the core mechanic behind a platforming game is being able to jump and land on platforms. But to be able to jump and land, we also need to be able to fall. So today in Snap, we'll be doing a very simple way to simulate physics inside of our game world. So all that we're doing today is we'll be programming objects so that if they're not touching something that they recognize as the ground, then they will fall. I've done 3 examples here. You only need to do one of these, but I'll show you the 3 different versions so that you understand the pros and cons of each. But what your program should do when it's all done is your object should rise up to the top of the screen and then fall down to the ground and land on the ground. So to get our objects up to the top of the screen, it's really simple. I use a go to X and Y to get this brick to start at the bottom, and then I use a glide for 3 seconds to different coordinates. I go from -335 in the Y, that's all the way down here, to +300, which is all the way up here. So let's do a quick demonstration. Let me break this apart and execute just this piece of code. It goes to the bottom, and then it glides to the top. Now you might be thinking, if all I need to do is make an object go from the bottom of the screen to the top and then back down to the bottom, well, I can just reverse this glide code and have it glide back down to the bottom. So if all we wanted it to do was move up and down, you'd be right. But we don't just want it to move up and down. We want it to be able to fall. So for example, if I were to execute my code right now with the brick on the left kind of taken apart and the bricks in the middle on the right working normally, if I click on this brick right now, well, it just floats wherever I drop it, which is kind of what you're used to with most of your sprites. But these sprites, with their programming intact, if I were to pick it up and then let go of it, it falls to the ground because the game is still running, and these are designed to fall whenever they're not touching the ground, which is very different than just moving something up and down. If I were to connect this code back together on my leftmost brick and start this again, now it will fall until it hits the ground. So how do we actually start writing code so that something like this works? Well, we're actually not even going to start with our brick, or in your case, you probably still just have a basic turtle sprite that looks something like this. What I want you to do first, before anything else, is I want you to draw a new sprite. You can see I've got a sprite down here called ground, and it's really just a green rectangle. This is a great way to start for a test project like this. So to create a new sprite and paint it to look like something different than our little arrow, instead of clicking on this arrow right here, click on the paintbrush. And to make a quick green rectangle for your ground, just click on a green color, and then click on the filled rectangle shape, and draw a rectangle that goes almost all the way across your screen like that. And then I'll hit OK, and now I've got my new ground. Now while this looks like ground, it doesn't behave like the ground. You can see if I pick up this brick and I drop it, it lands on my original ground. But if I drop it on my new one, it falls right through. So why is that? Well, if I look at my sprite, so if we take a look at this touching block, I can find it in sensing, and you'll see a touching color block. Now these blocks can be useful, but they also create a lot of lag in the game, which is why we're going to avoid using color for this project. So we'll say if touching, and by default it says mouse pointer. But we can change it to be a bunch of different things in our game, including any sprites that we've created. So my new ground right now is labeled sprite 2. If I were to change this so that it says when touching sprite 2, and then let's add something in here. Let's say if it's touching the ground, and you can see I just pulled that apart, and it fell through because that wasn't holding it in place anymore. And I'll say now if it's touching ground or sprite 2, which is my new ground, that it should land on that. Now I've only put this code on the far left brick, so these two will still fall through my new ground. But this one will now land on either one of these pieces of ground. So that's how the ground works. I don't need the second one in here, so I'll just delete that for now. And let's go look at our first brick. So if we were to build this from scratch, we would just bring out a when clicked, and then we tell it where to go to. So we go to our motion and bring out a go to, Now you'll see I've used negative 200x and negative 335y. You've probably also noticed by now that my stage is taller than yours. I did this because when I'm doing a demonstration on how to drop something, well, it's helpful to make it taller. So if you don't change your stage size, you will want to change the numbers that designate where your object starts. Because if you use a y of negative 335, well, that will probably be off your screen. But now's a good time to know if you do want to create a bigger stage, you can click on this gear right here, and then you can go to stage size, and you can see I'm using a stage width of 600 and a stage height of 800. So if you want to make your project look exactly like mine, you can change the stage size to look like this, or you can use the default stage size, or come up with your own stage size. Any of that's fine. But remember, if you don't use my stage size, you'll have to pay close attention to what X and Y positions you're moving to, because these could be off your screen. So once you tell it where to start, then we tell it to glide, using another movement block here, to glide up to the top of the screen, where I've input those coordinates. And then we go to Control, and bring out a forever block, because we want to be always checking to see if we're on the ground. We are forever checking to see if we're on the ground, and if we're not, we're falling. So then we bring out an if-else. So forever, if we are sensing that we're touching the ground, then what do we do? Well, y determines whether we're going up or down, or how high up or down we are. So we'll change our y by 0 if we're touching the ground. So we can simply go to Motion and find Change Y by, not Set, but Change Y by. Change Y by 10. We're going to change that to 0 because this is saying if we're touching the ground, we're not falling. However, the else means that we must not be touching the ground. So anytime that we're not touching the ground, we will, again, change Y, but this time we'll change it by a negative number. In my original, I put negative 12. Any negative number would make it fall, but the lower that number is, the slower it will fall. So once we have this all put together, it should work exactly as we intend. So if I put this all together on my new sprite, that's this little red arrow here, which is probably what most of you are still working with, and I punch in all my values, now this sprite should behave in just the same way as my bricks. And if I pick up this sprite and drop it, it should fall. And one thing to keep in mind, when you're setting up the if touching ground, when you have the touching block and you click on this arrow, you're going to see a list of some things that are always here, like mouse pointer, edge, and pen trails. But below this line, you'll only see a list of sprites that are in your scene. So if you don't see ground, it could be because you haven't made a sprite for your ground, or it could be because you've made the sprite, but you haven't renamed it. So if you want your code to look just like mine to make it easier to follow along, when you make your ground, make sure that you come up here and actually name it ground. Of course, you could just say when touching sprite 2 or sprite 3 or whatever sprite represents your ground. The name doesn't really matter, but when you're looking at your code, if you have it named ground, it can make it easier to understand what's going on. It's kind of like naming a variable. So this is one way to do it. But if you look at my bricks as they fall, you'll notice they all fall a little bit different. The fall on the left, the one that we just programmed, is probably the least convincing. It goes up and then it falls down at a completely steady speed. But in real life, when you drop an object, it doesn't fall at the same speed the entire way down. It would gain speed as it falls farther and farther, up to an extent. Up to a limit. We'll get to that later. So let's take a look at this middle brick, which is programmed to gain speed as it falls over time. So you'll notice one thing that's different right off the bat. This time, we have variables, or really one variable used in two different ways. So let's look at what we're doing differently here. Now, I have some leftover variables from my experiments while building this program, but all that really matters is that we have a variable for y velocity. Because of my experiments, I've got a few versions of this, y velocity, and then 2 and 3. The name doesn't really matter. When you make this, just create a variable by clicking Make Variable and name it y velocity, or something along those lines. Then, as usual when we create a variable, we want to initialize it at the start. So here, y velocity is initialized to 0. Now my brick is still basically doing the same thing here. It's going to a starting location at the bottom of the screen, except this one is in the middle instead of on the left. It still says that forever if we're touching ground. But what we do is a little bit different once we check if we're touching the ground. Here we just changed y by 0, meaning that we're not falling. Here we're setting y velocity to 0. And so far it might seem like, well, if this does the same thing, why are we taking extra steps? But the next step is where an important difference comes in. Because below our if, and keep in mind this actually isn't an if-else, this is just an if statement, and then after that statement we do something else. So after our if, we have a change y, but we aren't changing y by 0 or by negative 12 like we did last time. We're changing it by y velocity. And then we change y velocity by negative 1, and we repeat this forever. Now, this can seem a little confusing, but what it's really doing here is we're changing our y velocity by negative 1, so the first time this triggers, it falls at a speed of 1, and then we loop this, and the second time that this triggers, it falls at a speed of 2. And when this loops again, it falls at a speed of 3, and then a speed of 4, and a speed of 5, and a speed of 6, until eventually this would be falling faster than the eye could see, and it might actually kind of break the game. But because we don't have a huge screen, we'll just see that it goes up, looking at the middle brick, and when it falls down, it gains speed as it falls. And here you've got a demonstration. Right now our y velocity is at negative 1. When I hit the green flag, it goes to 0 until it starts to fall, and it gains speed, and you see it goes all the way up to negative 27 before it hits the ground. 0, and then negative 2, negative 29. So this hits all of those different steps that are in between. This readout only displays about every half a second or so though. So we don't see every frame rate represented here, but it hit everything from 0 to negative 20 something before it hits the ground and stops falling. Now, this code right here is okay. If we use code exactly like this in your game, it'll be fine. Though it isn't completely realistic, and again, in a bigger game, if you could fall for a really long distance, this could become problematic as you end up falling too fast. So how would we fix that problem? Or make it more realistic? And I say realistic because there is this thing called terminal velocity. So just like we mentioned the first brick isn't realistic because when an object's falling in real life, it doesn't just fall at a constant speed, it does gain speed. But the middle brick isn't perfectly realistic either, because things don't gain speed until eventually they're traveling at light speed. They fall, and they gain speed, and go faster and faster until they hit a limit. And that limit is known as terminal velocity. For example, when a parachuter jumps out of a plane, the fastest that a human can fall is right around 150 miles an hour. So you don't just step out of an airplane, and immediately you're moving at 150 miles an hour towards the Earth. You gain speed over time, and after you've been falling for a while, you can reach a speed of 150 miles per hour before you pull the parachute cord. But you'll never go much beyond 150 miles per hour. Nobody free falling out of an airplane is going to end up going 500 or 700 or 10,000 miles an hour. It's just not possible. So here I've set a limit on my y velocity. My code for this last brick is almost exactly the same as the code for the middle brick. You can see this time, instead of using y velocity 2, I'm using y velocity 3, because I have multiple bricks in my scene. But really all I'm doing is I'm setting y velocity to 0, I'm initializing it, I'm telling the brick where it should go at the beginning. Then, forever, we check to see if we're touching the ground, just like in our other ones. If we are touching the ground, we set our y velocity to 0, so that we don't fall. Then, if we're not touching the ground, we change y velocity, just like last time, and we're still changing it by negative 1 every time that we loop, so it keeps gaining speed. But here, instead of just saying that we're going to change y velocity by negative 1, we say that we're going to repeat this. We've got another loop in here. We're going to repeat this until y velocity is equal to negative 12. So the brick on the right will never fall faster than the brick on the left, which is set to constantly fall at a speed of 12. It'll actually fall a little bit slower than the brick on the left when it starts, and eventually will reach a speed of negative 12, and then stop there. So we'll see it rises with a speed of 0, and then when it's dropped, it goes up to a speed of negative 12, but never surpasses that. So our first brick is a very bare-bone example piece of code that does do physics simulation, but not very well. We can drop it, but it doesn't feel that great, and it's not very believable. Our second piece of code, this works very nicely and should do just fine for anybody's game that they're making this quarter. So I recommend this code as a good practice for what we're doing next. And if you complete this code and share your Snap project with me, you'll get full points. If you want to take the extra step and program your object to have a terminal velocity limit, it's not a whole lot of extra work, and I'll give you a few extra credit points, and it'll probably turn out a little bit better in the end. So you can create either this piece of code right here, or this piece of code right here. Remember, you may need to change your X and Y's here depending on your stage size, and remember that the touching ground, you're going to have to find whatever you named your ground to make this work. But if you build this, and you test it, and your object drops, and rises appropriately, then you're good to go for the week. If you've made it this far, this should actually feel pretty easy compared to some of the work we've done over the last couple of weeks. Next week, we'll start planning out for our 2D platforming games. So when you get your work done, remember to save it, share it with us in Schoology, and until next time, good luck and have fun.